Okay, good afternoon. Do we have you? I don't see you up on display yet. Yeah, let's get you going. Make sure you're up there. All right, it's syncing. And game on. Awesome. So you guys are awake? Cool. Otherwise, I mean, we could flood you with more coffee or something. All right. So, couple housekeeping things first. You are in Ballroom C. That is the anything track. If that's not where you want to be, run now because we're locking those doors in 10 seconds. Okay, maybe not. Second thing, I wish I didn't have to say this, but I always do. Cell phones, silent, turn them off, do something so that I don't have to come out there if I hear your cell phone and, start making use of the boots I decided to wear today. And then finally, pay attention, enjoy. We are going to be talking all about evasion techniques for AI-powered malware, endpoint protections. You get the idea. We hear it all the time. Lots of folks over in that vendor hall talking about it. So our next speaker is going to tell you all about how attackers are getting around it. So you've heard enough from me. It's time to introduce our speaker. Here he is, Dan Allen.
Thank you. So I know it's 4:30, so second to last session of the day. You guys probably have a little bit of PowerPoint fatigue at this point. So I promise you the 62 slides that I have here, I'm going to do my best to get through them in the 25 minutes as fast as I can. No, so in all seriousness, I think I got like 5 or 6 slides I'm going to share with you, and then what I'm actually going to do is do a live demonstration, demo Gods Be Willing, to show you some new cool technology that we've been developing, and hopefully get you thinking about different ways that you can go about protecting your environment. So first, you might notice that in the schedule it says I work for Bromium. How many people here have heard of Bromium before? Endpoint security software company leveraging virtualization in order to provide enhanced security. So I'm happy to announce our company was actually acquired by HP last month. So I'm now Dan Allen working for HP. Hopefully I won't get in trouble due to the fact that I've still got a Lenovo laptop sitting up here on the podium. At some point we'll get that swapped out, but that's just on the to-do list for now. So I'm VP of Customer Success at Bromium and now at HP, where we're going to be continuing, and I'm actually excited to be a part of HP, because at Bromium we focused on using virtualization and hardware to enhance security. And now that we're actually owned by a hardware company, it's going to open up a lot of new possibilities for where we can take our tech and tie it to the hardware to make it even more effective. But what I want to talk to you today about is, artificial intelligence and machine learning. So how many people here have some sort of AI or machine learning powered security solution in your stack today? Okay, about 25% of the audience. There's been a lot of hype the last couple of years about machine learning and artificial intelligence is somehow going to solve all of our security woes. Well, the reality is it is just hype. Anytime somebody says, whether it's, virtualization is going to solve it, the cloud's going to solve it, AI is going to solve it, no one technology is going to solve all of our security challenges. If there was one silver bullet out there, we'd have already found it, and none of us would be needing to sit here because we wouldn't have to worry about how do we secure ourselves against all the threats and the risks that are out there. So what I want to do is talk a little bit about, how AI and machine learning actually can help us, because there is a role for it to play, but you can't view it as a silver bullet. And, at the end of the day, why we can't view it as a silver bullet is it's just mathematically impossible to predict whether something is good or bad and have 100% accuracy. You're never going to get 100% accuracy. Is that a shark or is that a dolphin? If you get it wrong, you might end up dead, right? Or maybe you're playing with Flipper and it's actually not that bad of an experience. But to be able to predict it with 100% accuracy is just, it's mathematically impossible. The amount of combinations on things are infinite. And when you're just trying to do static analysis of a file or whether you're trying to predict whether that thing the user's about to open is going to be good or bad, you're inevitably sometimes going to get it wrong. Now, it doesn't mean that we shouldn't be using machine learning and artificial intelligence to make our detection engines more efficient and effective, because we certainly should. And I think there are some great technologies out there on the market, and there are some companies that have proven that this type of approach can add value and increase your defenses. But they're never going to be perfect. So it's important to understand how to separate the hype from the actual benefit that you're going to be able to potentially get from these types of tools. So one of the things that we've done at Bromium, if you go to the bromium.com website, still up, and there's a blog section on there. And we've done quite a bit of blogging about some of the recent Emotech campaigns that have been out there. And that was an interesting example to look at. Because what we found, and when we go into customers, oftentimes the Bromium solution is complementary to the existing. They still have traditional antivirus. They might have a next-gen machine learning security tool, and plus they'll have our isolation tool. And we find that malware is still getting through all of those next-generation defenses. And even at customers that have the latest AI-powered defenses, we're seeing the bad guys just become more clever in how they disguise the malware. And when you look at Emotet specifically, malware doing the exact same thing, they're just making it highly polymorphic. They're making it so that the code is indistinguishable. One person's attack is actually unique from another person's attack, although at the end of the day, it's the same command and control servers and the same types of malware they ultimately end up infecting you with. But they're just making the malware unique. And this is something that we're finding, and why we all know that traditional antivirus, just using signature detection, fails, because you just make the malware unique. And so there is an interesting vulnerability that was exposed, and I'm not going to use names of different cybersecurity companies, but in July, there was a group out of Australia, and SkylightCyber.com. Has anybody read this, know what threat report I'm referring to, that Skylight Cyber found? If you go to their website, you read a great blog article about it. But what they did is they targeted one of the most popular and well-known machine learning next-gen security tools that were out there, and wanted to see, well, could we trick it? Could we trick its algorithm into marking something malicious as known good? And at the end of the day, it wasn't that difficult for them to do it. They just reverse engineered how some of those algorithms were working, how the machine learning is making predictive decisions by looking at properties or doing static file analysis and saying, yeah, that looks like it's a clean file. And they were able to just masquerade malware with the same properties that the machine learning algorithm was trained to treat as benign. And they pretty much were able to get any piece of malware, even WannaCry and off-the-shelf stuff that was really old. They could easily redisguise it, and it would slip right through this machine learning software. Now, again, it doesn't mean machine learning is bad. It just means we're never going to be able to accurately predict. Because at the end of the day, who's creating those machine learning algorithms? Right? It's human beings that are programming it for what to look for. So there's always going to be flaws in how it's doing its predictive analysis. So these guys blew right through it, blew it apart, and on a positive note, they shared those results. And guess what? That company's solution is probably even more secure now today, because now they've programmed the new algorithms to be able to detect that kind of a bypass. But the reality is, when you talk about detection, if I'm going to let a file drop onto a PC and then potentially execute, if I'm relying on detection, I'm never going to be 100%. There's always going to be some clever bypass in order for the bad guy to be able to disguise his malware and trick pretty much any security tool into marking it as clean and letting it run. If we could solve this problem with 100% certainty, again, we wouldn't be sitting here today. The other thing with machine learning and artificial intelligence is that, well, it's not just good guys that use it. So what we're actually starting to see now is some of the threat actors using the same techniques with artificial intelligence and machine learning to improve the quality of their malware and to improve their attack techniques. So it's actually a double-edged sword, right? We can use machine learning, we can use artificial intelligence to do good things. We can also weaponize it and use it to do bad things. And don't think for a minute the bad guys aren't using the same kinds of techniques to make their attacks more effective, more stealthy. How many folks here have a SIM tool or, I mean, I hope more than this have actually SIM tools, right? You have Splunk or ArcSight. Or how many folks have like an EDR tool that does a lot of endpoint collection of processes, like a Cyber Reason or a Carbon Black or something along those lines? So when you think about the volume of data that you can collect, right? This lady's basically holding up the SIM tool, right? And we're just collecting a massive load of crap. And how do you sort through the crap or cut through the crap in order to find that little gold nugget that might actually be there and be useful? See, this is where I believe machine learning, artificial intelligence is going to have the biggest role for us to play. The amount of data we're collecting today, all of these tools, and they're cool, with Cyber Reason, Carbon Black, all these tools out there are very effective. We can't hire enough analysts to parse through that data to get true meaning out of it. Think about Microsoft with ATP and with Windows 10 and all of the threat telemetry that they can collect today. And a lot of people opt in to share it, or they've got customers using ATP. Microsoft is collecting a massive amount of threat intelligence. There's not enough human beings, security analysts on the face of the earth, to probably sift through that volume of data that a company like Microsoft is collecting from hundreds of millions, if not billions of PCs. So this is where machine learning and artificial intelligence are going to create the next revolution of how we sift through that data and do it in a fast, efficient manner. And how do we look through this giant volume of data, cut through the crap, and get to what really matters? But the important thing to keep in mind is it'll never prevent the first breach. You're always going to end up with some patient zero or a sampling of patient zeros, maybe across your organization, or it could be across multiple organizations if you're Microsoft and you're monitoring the security on behalf of multiple clients. And then your algorithm's going to pick up on a pattern and identify that something is malicious. So machine learning will speed our ability to do detection and sift through the data so that then we can take action. So that then we can identify, wait a second, that is malicious command and control traffic. Let's just go ahead and automatically update our proxy and firewall rules so that we don't allow any of that traffic to proliferate. And now we can quickly identify, with the volume of data we've collected, what are the 20 or 30 machines in my environment that actually got hit with that specific attack. So there is a key role for machine learning to play to help us go through the volume of crap that we're collecting out of all these tool sets that we have. So at Bromium and now HP, we believe an effective tool you can put into your tool belt, again, not a silver bullet to solve all challenges, is to actually leverage the power of the hardware to do something we call virtualization or isolation. And when you think about the computing power in any desktop you buy today, especially compared to 10 years ago or 15 years ago, we've got a massive amount of compute power, and pretty much every chip that gets manufactured in the last 10 years has our virtualization engine built into it. It has all of the virtualization extensions that are there, and PCs are shipping with, it's hard to even buy a PC with less than 8 gigs of RAM nowadays. So that we can leverage that amount of power. And why use virtualization? Because if I take something like a Word document that I get from an email sender that's never sent me an email before, trying to predict if that Word document is good or bad, mathematically impossible. At some point, I'm just going to have to open it, and maybe it kills me, maybe it doesn't. But through the power of virtualization, what if I could just open that Word document seamlessly to the end user, invisible to the end user, but drop it into a virtual machine for execution, and let it execute there, and just do that on their laptop or their desktop or even inside their VDI session. And that's what we do. And the reason we do that is it's not that it's 100% effective. Nothing is 100%. But the ability for malware to escape a VM or perform a VM escape operation is infinitely harder than just trying to compromise the host that it's running on. So by running things that you don't trust, and actually what I'm going to demo you is the flip of that, perhaps running things that you actually trust inside of a virtual machine can give you an additional layer of protection that makes it significantly harder for the bad guy to actually cause compromise. Because they're going to have to figure out how to attack the properties of the hardware itself, or how to do a hypervisor escape, which is infinitely more complex than just doing a word escape or tricking a user into running a macro. So, why don't I just show you some things at this point? So I've just got a standard Windows 10 laptop up here. I have loaded Bromium technology onto it, rebooted it. It's just, our software is an MSI package that you install on a machine, you do a reboot. And what that allows us to do is basically put some hypervisor extensions into the operating system and onto that PC that allows us to create efficient, lightweight virtual machines. Now, why would I want to put something in a virtual machine? Let's go with the assumption that this device is actually compromised. And so you can imagine the bad guy has already infected the device. He owns it. He's got a remote access toolkit on here. He's got keyloggers. He's got screen scrapers. So let's just go with the assumption that the device is owned, and I haven't figured that out yet. So what I'm going to do now is actually open up a keylogger. This is a little just a benign PowerShell keylogger, but you can imagine if I was the actual bad guy, the remote shell wouldn't be running here. It'd be running back on my command and control, and now I can collect all the keystrokes that happen on this device. So when I, as a user, I run Notepad, you can see the keys are being logged. Now, it's bad enough that the bad guy's tipped over this machine and has access to whatever this user has access to. But let's just take this one step farther. What if this user is actually a privileged user? What if this is actually an admin, and hopefully we're doing basic hygiene where at least you have separate accounts for your administrative work. But what do most admins do when they want to go administer a server? They fire up an RDP session. It's a pretty common thing for them to do. So I'm going to pop up my RDP client. Now the remote RDP server I'm going to connect to is not in the same Active Directory forest as this laptop device. They're two completely separate networks, completely separate server that I'm going to be connecting into. Now, again, if I've got the remote access toolkit and a keylogger here, you can see my password would end up being typed. Now, I didn't actually type my real password into that because I don't want you guys to see my password, but whatever I type as a password, now I've stolen the password of that admin. I also have a screen scraper. I could simply see the name of the admin user account that's being displayed as well. So let me actually go ahead and just close the keylogger because I don't want you guys actually seeing my real password. And I'm going to go ahead and start this RDP session. Now there are, and if you aren't using them, I would encourage you to look at them, privileged access management tools out there that can eliminate the need for admins to even have to know their passwords. Companies like Beyond Trust have technology. Companies like CyberArk, I think I saw CyberArk has a booth here. They make really cool tech, right? I would encourage you to check that out. And they help solve that problem of bad guys stealing the admin credentials. But let's just assume I even did have a CyberArk technology on here, and maybe I never had to type my admin password. All that got handled for me automatically by CyberArk. Can the bad guy still do something malicious inside this RDP session? So what I'm going to show you now, let's just open up Active Directory users and computers. Again, this just happens to be a domain controller in an isolated forest that I have. If you look here, there's 3 user accounts that are existing inside this domain controller. So let me just go ahead and close Active Directory users and computers. Let's come back to my bad guy toolkit. Now I've got a remote access toolkit. I'm the bad guy. I can see that person has now made his connection to the RDP server. I'm still collecting all the keystrokes in the RDP session. So if I come back and I fire up my keylogger again, as I type in the RDP session, all the keys are getting logged. But if I had a privileged access management solution on there, at least I wouldn't have scraped the password from that admin session. But without having to scrape the password of the admin session, if I come back to my bad guy toolkit, I'm going to go ahead and execute code, because I have code execution on this Windows 10 device. I'm going to go ahead and execute code that's actually going to interact with the RDP session and the RDP process that we could see was running on this desktop. And so what just actually happened, let me reopen Active Directory users and computers. And now, from this Windows 10 device, which is not joined to the domain that I'm RDPing into, there's a new user account sitting here. A user account called bad guy. And if I open it up and look at the member of, he's a domain admin. So I, as a bad guy, having remote execution into this Windows 10 device, can just sit there and wait. And even with a privileged access password manager solution, I didn't get your password, but I can wait until I see that you're in that RDP session I want to interact with, and I can actually get code execution from the host into the RDP session. So how do you protect against something like that? That's a really difficult thing. If the device is already compromised, how can I guarantee the user can do something that won't also end up being compromised? And this is where we believe the power of virtualization can help us solve this problem. So what I'm going to show you is some tech that we've been developing at Bromium, and now we'll continue to work on this technology as part of HP. I'm going to disconnect from this RDP session. Now I'm going to relaunch it. I'm going to right-click that same RDP file. I'm going to do Open with Bromium Protected App. Now, this is all going to get rebranded. Will it be called Bromium Protected App in the HP land? Don't know. Probably come up with a different name. But now, what I'm going to do is go ahead and log into this RDP session. And you'll notice I'm not closing the keylogger because I don't care that there's a keylogger running. Hopefully I typed the password correctly. Because that keylogger saw none of those keystrokes. So what did we actually do there? Well, when we got our Bromium technology installed on this Windows 10 device, without having to reformat the device, without having to set up new partitions or slide the disks around or do anything funky like that, just simply installing an MSI package and rebooting it has allowed us to drop a lightweight UEFI bootable hypervisor onto this Windows 10 system so that we can actually create virtual machine contexts that have a higher privilege and run at a lower ring level than the actual Windows 10 OS. So at the end of the day, what does that mean? Simply means we can, when I'm interacting with that protected application, because we're taking advantage of the hardware and running on the hardware and device, I can reroute the keystrokes of the keyboard. I've actually unplugged the keyboard from the Windows 10 operating system, and I've plumbed it straight into the virtual machine. So any keystrokes that I type away on this device, the Windows OS that's running here, those keys are 100% invisible. It is impossible for you to snoop those keystrokes because they're not actually being routed through Windows anymore. We're routing them through a tiny little UEFI bootable hypervisor that's running underneath Windows without the need to actually rebuild the machine. Just install, reboot. Now, what I've done is I've actually launched a tiny little Linux VM. We're using Linux in this kind of scenario because it's a very small, lightweight, small footprint. And I'm just running a Linux-based RDP client to make the connection. Additionally, when you think about screen scrapers, we can also do funky things like blanking out the frame buffers. So now, when I'm as a bad guy, I'm trying to screen scrape that session, that RDP session comes back blank because we have the ability to control the frame buffers that the VM is using and making those hidden away from the actual Windows 10 OS. So what we can do with the power of virtualization, I just want to get you guys thinking about how virtualization can be used. And Bromium, now acquired by HP, is not the only company in this space. There's other technologies out there. There's companies like Isolate. There's remote browser solutions and others out there. want you to just think about how you can leverage virtualization and isolation to try and solve some of the security challenges that we have today. Whether it's running potentially malicious Word documents in a VM so that they don't infect my host, or if it's just simply allowing your administrators to launch secure RDP sessions in a protected VM so that you don't care if the machine's compromised. Now, the bad guy, yeah, it's bad enough he owns this device, at least he'll never own anything in my RDP session. But it just kind of highlights the power of virtualization, the power of isolation, and how we can just add this as another tool into our tool belt to make our environment more secure. All right, I think I've got 1 minute left, so probably don't have much time for questions, but if anybody has a question or two, maybe we can take one now, and I'll certainly be around if you guys want to chat to me afterwards. Yep. So these BRUZen processes, these are the represent the actual secure VM contexts that are running on the device. You can see 50. The one with the CPU cycling is the active one that's got the RDP session. So that RDP session is using 2-3% of the CPU right now and has consumed about 50 megs worth of memory. So pretty lightweight. Again, why we're using Linux for this particular VM context in order to keep the footprint down. Cool. All right. Well, guys, hopefully you found that to be useful. I thank you for your time and enjoy the rest of the show.